going on, guys? So today we're going to be solving questions 26 and 27. This is from the SAT number 9, and let's jump in here and solve it. So first thing is that we have a paired question here, 26 and 27, which means we're going to start by reading this question for 26, try to pick an answer choice from 27 based on that, and then use that text to answer 26 again. And this is kind of a difficult question. It requires some attention to detail, a little bit of back and forth. So I think it's an interesting one to kind of practice. So let's go over it. So 26 says, based on the passage, Bottke and Levison's conclusions would be most weakened by a study that did something. So here we're talking about Bottke and Levison's conclusions being weakened by something. So this kind of question here kind of falls in the realm when we're talking about a science experiment or a science study, and we're talking sometimes about basically the logic of their conclusions. And there's a few questions, not a whole lot, but a few questions that deal with this. And sometimes they'll be talking about an assumption that so-and-so did in setting out the research, or they'll talk about the conclusion depends on this. So what we're really looking for some sort of chain of reasoning, right? Some sort of logical reasoning. And we're looking for any kind of assumptions that the passage will tell us. So really, we're going to go through each one of these lines for 27 and just basically be looking for something about their conclusions and something about sort of their reasoning of their logic, or maybe an assumption that they made. So let's jump in for that. So 27 says 39 through 41, which starts by saying Bottke and Levison of SWRI led a pair of studies which support the idea of refugees from the outer solar system orbiting in the asteroid belt. And my first instinct with this question, or with this sentence, is that it's not going to be very good to answer our question. All this is doing is introducing the study, and it's saying, here's what they studied, here's these people, etc. So it's very factual, it's very preliminary, it's just very introductory. So I don't think there's anything in here which talks about the conclusions or kind of hints at something that could weaken their conclusions. So for that reason, I'm pretty confident in getting rid of A. 42 through 44 says, they focus on the so-called D and P type asteroids that comprise 20% of the population in the outer part of the belt. So this is, again, sort of talking about their methodology, sort of explaining their experiment, just telling us what they focused on. And again, you know, if we dig deep enough and we think hard enough, maybe we could figure out some sort of assumption or chain of reasoning here, or something that could weaken their conclusions. But to be honest, it's going to require a little bit of digging, too much for right now. So I'm going to just keep going and look for something a little more obvious. But I don't really see much here, and I don't think that this is likely to be our text. So I'm going to eliminate it for now. 44 through 49 says these objects are dark reddish color that suggests they are covered in carbon-rich gunk, just the sort of residue that might have been left behind on an icy object that had its outermost layers vaporized in the bright sunlight of the inner solar system. So for this reason, I think this is maybe a little more plausible. We're still kind of just explaining about what these objects are, but we have sort of an assumption here, right? Just the sort of residue that might have been left behind on an icy object that had its outermost layers vaporized in the bright sunlight. So maybe if we found that this residue, in fact, wasn't burned off, or this is not what you would expect if it was burned off by an icy object or something, then this would kind of weaken their conclusion. So I think we could keep it. Then we have 49 to 53, which says, Bottke and Levison's computer simulations show that the observed number of objects is about right if they are immigrants, though they have assumed many of the objects broke up after transport. I also think that this one is pretty strong here because it's basically saying that their conclusions check out. It shows that all the number of objects is right. Of course, they've assumed this, that many of the objects broke up after transport. Whenever we're talking about a scientific passage, anytime that the author or the researcher makes an assumption, that's pretty interesting. The SAT likes to focus on that. So I'm going to keep this in mind as well. So basically, the two things that I think could kind of weaken their arguments would be for C, if that residue, in fact, isn't what you would expect, or they didn't have their icy outer layer burned off, or something down here which says that they didn't break up after transport. So let's go through the answer choices, see if we find something to match one of those. A says their study would be weakened if we found that or they confirmed that the heat from the sun burned away the outer layers of all immigrant objects. So that the heat from the sun burned away, blah, blah, blah. But this is actually kind of the conclusion. This is the exact conclusion that they made, right? This is sort of what their findings depend on, right? In these lines here, it depends on the fact that the sun burned away those outermost layers. So this is going to be wrong. It wouldn't weaken their claim. It would support it. B says if they establish that the orbits of certain objects in the inner solar system were once less stable. And if you think about this, this is kind of irrelevant for their experiment overall. You know, their study sort of depends on the fact that systems are like Uranus and Neptune, Um, so it actually, to be honest, this depends. You can interpret this in a number of ways. So basically, their study or their finding depends on the idea that Uranus and Neptune, which are in the inner solar system now, once were not, and they sort of just rampaged, right? They migrated from the outer solar system inwards. So maybe we're talking about those certain objects, or Uranus and Neptune, right? Were once less stable, but their study depends on that. So this is not a good answer choice. Or it could mean that there were inner solar system or objects in the inner solar system that got pulled along from Uranus and Neptune, which again is just sort of irrelevant to their argument overall. So at best, this would support their argument, and at worst, it would just be irrelevant. So it's not going to weaken it. Let's get rid of B. C says they demonstrated that very few objects broke up after migrating to the asteroid belt. And this is going to match answer choice D. Remember, D says they assumed many objects broke up after transport. So if it was found out that very few objects broke up after migrating or after transport, this would weaken their argument for sure. So we can keep this one. D says they proved that not all immigrants from the outer solar system survive in the asteroid belt today. Prove that not all immigrants from the outer solar system survive in the asteroid belt today. So this is basically saying that objects that were from the outer solar system that got dragged by Uranus and Neptune into the asteroid belt, that they didn't survive there today. Their argument kind of depends on this, right? So it kind of depends that objects were broke up after transport, which I think is not surviving in the asteroid belt today, or at best it's just irrelevant because they don't mention that basically every object in the outer solar system has to survive still in the asteroid belt today. So I would give rid of D. And that's going to leave us with answer choice C from 26 and answer choice D from question 27.